This lecture is on the respiratory system, beginning with the mouth, pharynx, larynx, and trachea. So then respiration starts then with air entering the mouth and the nose. You knew that. And the air enters by way of what is called negative pressure, which is a lousy term, but we are stuck with it. So this is negative pressure then created by the diaphragm. Okay, what do I mean by negative pressure? What I really mean is suction. Basically, when your diaphragm, which sits at the base of your chest, when your diaphragm contracts, it goes down. The diaphragm is a dome-shaped muscle. When it goes down, it increases the volume of your chest cavity, and that reduces the pressure, and that basically pulls air in from the outside. Basically, you're sucking in air, as you probably knew. So what happens when the diaphragm contracts is that a partial vacuum is created in your lungs and you take in air. That is what is known as negative pressure. Now, a physicist will tell you there's no such thing as negative pressure, and that's true. But the term refers to basically this partial vacuum created in this way. So that is what is known as negative pressure. So the air, therefore, enters your respiratory system by way of the negative pressure created when the diaphragm contracts. And the air then passes through the pharynx, which I hope you remember. This then is a common tube for air, water, and food. We talked about the pharynx when we were talking about the digestive system. So then, from the pharynx, air enters the larynx. Okay, so the larynx then is basically a cartilage structure. I will get more into the details of how it is put together in another lecture. It houses your vocal folds, which are known as the true vocal cords. And the most prominent cartilage in your larynx is what you see here, known as your Adam's apple. So when you find your Adam's apple, you have found your larynx. The trachea will be below it. The vocal cords are inside that larynx, which is why if you push on your larynx, you can change your voice. So the larynx then sits on top of the trachea. Now, the important thing about the larynx and then about the trachea is that you are finally separating out the respiratory system from the digestive system. Remember, at the pharynx, you always still have the digestive system with its food and water using the same passages as the respiratory system. But now we are finally getting to the point where the air is on its own, starting at the larynx and then going into the trachea. However, the trachea is one of two tubes in the throat. The other one is the esophagus, which you have heard about already. And so if we were to look at an anterior view, you would have the trachea here. Posterior is going to be here, just so you know what's going on. I'm just drawing you a picture. And then you would have the esophagus back here. So then here is the esophagus. So what I'm getting at is you have the trachea here, then right behind the trachea you have the esophagus, the tube leading to your stomach. And they are very closely aligned with one another in terms of position. You have the trachea going down, you have the esophagus right behind it. In fact, there's loose connective tissue holding those two tubes together. So the esophagus is immediately behind the trachea. Okay, but there are some structural differences between the two. Let's start with the esophagus then. So the esophagus then is very expandable. It's almost a floppy tissue with a lot of room for expansion in it, which makes sense because that way you can swallow things and they will manage to get down it. So as I said, the esophagus has this very sort of floppy expandability about it. The trachea is very different structurally. So the trachea then is actually held open. That's why I drew it that way. Whereas the esophagus, when it's not in use, it kind of collapses down to, it's almost a flat tube, if you will. A trachea, meanwhile, is held open by C-shaped rings of cartilage. So in that view I showed you a moment ago, now I'm just going to do the trachea itself. So here we have the anterior view, and here we have the trachea as a whole. But what I'm getting at is that in the front of it, I'm going to use blue for cartilage now. The front of it then, in addition to having soft tissue, has cartilage going most of the way around like this. So this now is cartilage. And then at the back, at the very, very back, we've got a little bit of soft tissue, including some smooth muscle there. So the trachea is actually held open. It's really difficult to collapse the trachea. So the trachea is held open in this way. So why do we have that? First of all, just in general, this means that food in the esophagus, which, as you recall, the esophagus is just right there. It means that food in the esophagus can't push into the trachea, which might block it. You wouldn't want the esophagus basically pushing all the way into the trachea and blocking your ability to breathe. But the other really important reason here is that without being held open, the trachea would collapse inward. Every time you inhaled. Here's what's going on with that. Remember what I said about this vacuuming that you do when you inhale. So you have all of this suction, basically, that is taking place as you're pulling air down. And that would actually cause the trachea to collapse inward like this every time you inhaled. And so we don't want that. And so it's fortunate for us that we do wind up having this trachea that has the cartilage reinforcements just holding it open like this. So as a result, the trachea is somewhat rigid. I'll even write that down for you. So the trachea then is flexible as a tube, but somewhat rigid. It's held open so that we can continue to breathe each time that we inhale. If this didn't happen, as I said, it would collapse inward, and in fact your pharynx, which is made of soft tissue, not at the hard palate, but further back at the soft palate and the like, you can wind up having that soft tissue collapse, and when that happens, that is what makes people snore. The snoring is basically that passage collapsing inward briefly for quite a while. And it is possible for people to actually wind up having that passage collapse inward and stay collapsed inward so that they can't breathe. This happens sometimes when people sleep, when their muscles are relaxed and they're on their backs and the tissue is flopping down and the like. And that is how people get the condition known as sleep apnea, where they stop breathing when they are asleep sometimes. And what happens then is that the people will wake up gasping for breath. And this can happen, in fact, hundreds of times a night and can be a very debilitating condition. So on the outside of the trachea, or I should say in the wall of the trachea, more to the point, making up the wall of the trachea, we have those cartilage rings. I'm just going to briefly say that inside the trachea, so in the lining of the trachea, there are cilia. Now you remember cilia. Cilia then are those cellular projections that project outward from a cell. So what happens in your trachea, I'm going to draw the walls of the trachea, and then here we have the interior of the trachea, and you have these little hair-like projections. Like so. I'm not going to draw all of them in. And you also have quite a bit of mucus in there. So you've got mucus cells and you've got cilia. And what this means then is that as you are breathing, if there are particulates, if there is junk in the air, it's likely to wind up sticking to the mucus, like so. And then what happens is that the cilia basically wave together. They do a standing wave like this, and that junk winds up getting moved up and out of your trachea up to your pharynx, where you can cough it out, or where you can spit it out, or where you can swallow it. If you swallow it, that's going to lead to the acid bath in the stomach. If you've been breathing in bacteria, that'll take care of them. If it's other substances, you can spit them out, cough them out, and the like. And this is part of the way that your respiratory system stays clean and keeps the air nice and clean for your delicate respiratory surfaces. And more on that another time. But that is the end of this lecture.